Yeah, well, we already know. We can do. I want to do this the right way. So we know from this, right, that the density, kind of like the submerged density times the submerged volume times gravity is equal to the object's density times the object's volume times this, blah, blah, blah. So then you get these things. And I mean, I know I'm doing this over, but I just want people to be able to kind of go through it. That cancels. And so we get this thing where it's the density of the submerged, or the liquid, whatever, shoot. I should have just called this submerged volume, and then this is the submerged height. The density of the object times the total height of the object. So this ratio is like, should take care of it. I guess we could have just used volume, huh? I don't know. Yeah, the ratio here and just seeing this needs to become like second nature when you're doing these kind of problems. So I guess that's why I went ahead and did it anyways. But I want you to get accustomed to always, okay, that volume trick is important. Yeah, so we can say, I don't know, just find the ratio of this. So let's see, which one do we want on top? Oh well, either way. If we take the volume of the object over the submerged volume, then the density of the liquid over the density of the object. And then this should, well, and then of course we have to say, oh, okay, that's what we're looking for. VIB is the volume submerged, so sorry, we can just solve for that. So from here, I'll just solve for that. So volume, oh, we don't know the volume of the object. Do this. We have to do like volume, like the volume of the object is equal to the volume above plus the volume below. So then if we do this and solve for the submerged part, then we can go here to get the, yeah, I thought it was going to come out. I mean, when you look at this problem, it's like logically, you just say, because the ratio of the densities should be relative to the ratio of the volumes. So you know 90% is below, but I don't know, actually coming up with the math is more problematic. Oh, at any rate, this comes out to be, we can substitute that, and we get VIA plus VIB over, and then this is VIB, because VS was equal to VIB over there. And then you have to solve this one for VIB. So let's see how that works out. Erase some of this stuff. We get the density times the water, density of ice times volume of the ice above the water, density of ice below the water. And then that goes density of water times volume of ice below minus density below density of ice. So volume of ice below the water is equal to density of ice times volume of ice above the water, density of water minus the density of ice. Is that going to work? Yeah, the mass of the ice, and this is the mass of the ice should equal the mass. Oh. Okay, does that make sense? So when the ice goes in, the mass of the ice, the total mass of the ice, should equal the mass of the displaced water. Is everybody okay with that? Okay. So then I just said, okay, well, what are these things? Well, mass of the ice is density of the ice times the volume of the ice, and this is total. And then this one is the mass of the water, the density of the water times water. Well, total mass has to include the mass above and the mass below. And we're given the mass above. And then is it not true that the displaced water, the volume of that water, is the volume of the ice below the water? Right? It's like if you get in a bathtub and you go down up to your neck, right? And then we calculate the volume of your head, right? Then like your ice. So like that's the volume of your head. That's the 600 meters. And the bathtub was filled like to the very top. So when you stick your finger in, some water pours out. When you get your whole body in, whoosh, does it make sense to you that the volume of your body below your neck is equal to the amount of water that poured out of the tub? That's what we're saying here. That the amount of your body underwater, the volume of that is equal to the volume of water that you poured out of the tub. Right? That's the whole idea here. Yeah, like an ice. This IA, it's the volume of the ice. And the volume of water, IB.
You were saying something about 10%. How did you know 10%?
Okay. So in finishing this, like when you solve this out, you'll get the same thing as the other one, right? So it algebraically. So I'm going to move this over to here. I got density of the ice, volume of the ice above water is equal to density of water, volume of ice below the water, minus density of ice, volume of ice below. So that means volume of ice below is equal to volume of ice above the density of ice over the density of water minus the density of ice.